Hi everyone, welcome to another of Ian's interviews. Today joining me is Forrest Norrod, General Manager of AMD's Enterprise and Embedded Semi-Custom Business Group, Solutions Business Group, and Senior Vice President. Did I get that right, Forrest?
Pretty close. It's the Data Center and Embedded Solutions Group now, but all things data center.
So that covers CPU, GPU, and you're involved in the semi-custom with the consoles?
I'm not involved in the semi-custom business anymore. I got those to the point of winning the next generation designs, and then focused all my attention on data center.
Which is one of the big targets for AMD this year. I think CEO Dr. Lisa Su said, was it enterprise and commercial are the two big targets this year?
That's right. That's right.
And you're talking to me today because you're about to launch, or this interview will go live as you are launching EPYC third generation Milan.
That's right. We're continuing the tour of Italy, and it's for me, it's particularly an important milestone because when I joined AMD about 6.5 years ago, just right after Lisa became CEO, and the mission was to get AMD back to relevance and then get it back to leadership in the data center. And we laid out this tour of Italy, Milan, first with Naples, then with Rome, and then Milan, and Genoa is next. But the first three steps we put in place, way back then, 6 years ago, out through Milan, and it's incredibly impactful for myself as well as the whole team to deliver that third step, which was part of the original plan. It's great to see. Team's done an incredible job.
So when we get back to flying again, at one point we'll be over in Italy celebrating a launch of a next generation EPYC.
I sure hope so. We had for Rome, when we did Naples, quite frankly, AMD was just getting back into it. We were the almost the scrappy startup again in the data center, limited resources, didn't have any funds for anything superfluous. But Rome, a little bit better, and so we actually did an event in Rome. We did a European launch event in Rome, sort of about a month after the worldwide event. And we had every intention of doing a blowout event in Milan for this generation. And I'm sorry to say that that didn't happen. But hopefully by the time Genoa comes around next year, we'll be back in Italy.
I'll mark it on my calendar, and hopefully I'll have a vaccine by then.
There you go.
So with the launch of new third generation EPYC Milan, we see the platform move from Zen 2 to Zen 3. Updates in performance, cache, Infinity Fabric. How is AMD positioning this family, say, compared to last generation or other competitive offerings?
I think again for us, it's sort of the next step. If you think about our strategy, in Naples in the first generation, it was about getting back into the market, demonstrating that we could produce enterprise class and cloud class product. With Rome, it was really about innovating around chiplets, being the first to 7 nanometer, and really taking unquestioned throughput performance leadership. And quite good per core performance leadership, or per core performance as well. With Milan, it's all about making the core even stronger, taking unquestioned per core performance leadership, and increasing the security features as well. To really bring that next level of cloud native security to the processor. So we view this as sort of the culmination of entry, throughput performance leadership, per core performance leadership now with Milan, and all the while building on security.
When you and I last spoke, it was around the launch of Rome, second generation, and back then we discussed, and the other leadership team discussed, that AMD was on a journey to achieve 10% market share, which in the middle of last year it was announced that AMD had reached that goal. Where do we go with Milan? Are there market share goals or specific wins? What measurements would make this product a success?
Yeah, well, unfortunately, we're in our quiet period right now, Ian. So unfortunately, I can't, and we're also trying not to set up specific market share goals in the short term. I will say that, in the long term, and we've said it before, we absolutely intend to surpass the historical high watermark share target or share that AMD used to have back in the Opteron days, which was about 26-27% unit share, 33% revenue share. And we certainly think we're on a drive to get back there, but I don't want to give you any intermediate checkpoints. I will say that we think that Milan is going to continue driving the business, and really it's incrementally more competitive than second generation. A big increment, but incrementally more competitive than second generation. And we think the customer excitement and traction we're going to get with it is large.
So, I mean, to that point, you actually perfectly led me into my next question. So, again, last time we spoke, I asked about partner solutions and AMD's ability to execute on partner demand. I think you said then that you had so many solutions that your partners wanted to do. You had to sort of pick and choose the priority ones to ensure the efficient rollout of the platform. Given that the performance of Milan, is even higher than before, are there anything you've taken from that last launch that you've rolled into this launch with regarding partner solutions?
Well, one of the great things about Milan is it is socket compatible, and of course software compatible, but socket compatible with ROM. And so for the customers that built ROM optimized systems, to fully exploit all of the features, the PCIe Gen 4, the memory capability, Milan is pretty much a drop-in replacement. So they can drop Milan into their existing platforms and solutions and get an immediate performance bump. So by doing that, we've got this strong foundation of everything that we did on ROM. We can immediately take advantage of, or our customers can immediately take advantage of on Milan. And so then, as we've thought about, okay, well, how do we continue expanding the ecosystem? We've then focused Milan on areas where Rome was good, but perhaps not unquestioned leadership around some of the per core workloads, and so that's where you see a lot of the new solutions. And then I would say the other thing that's really opened up quite a bit is we're getting wider and wider adoption of our security features. So you saw VMware. In addition to cloud, like Google recently introduced about 6-7 months ago, their use of secure encrypted virtualization for confidential computing VMs. You'll see others doing that here shortly. You saw VMware, add support for SEV to their on-prem as well as cloud offering. You're going to continue to see a lot of solutions roll out that really take advantage of the new security features.
I've got. I'm going to come to security because I think that's going to be a key point with Milan. But I guess I'd be remiss, for if I didn't ask about supply and demand, because AMD is currently facing a period of high demand, such as substrates and packaging. I don't necessarily want to focus on that specifically about how much you can provide. But how does this high demand period change how you implement Milan rollout compared to a typical enterprise launch?
I think that, I mean, the whole industry obviously is seeing an unprecedented level of demand. We've got, I think, across the board. I read as I was coming in this morning, yet another article about the demand in in semiconductors causing supply issues across the industry. We think we're in pretty good shape in terms of the absolute amount of supply that we're bringing to the table, and certainly we're prioritizing our enterprise products, as well as products for some of our very large customers, such as the console guys. But so I don't think we view the launch as being any way supply gated. It is a question of prioritization.
Earlier this year at CES, CEO Dr. Lisa Su, highlighted AMD's enterprise division as one of the two key focal points for 2021, alongside the commercial sales. So this is because AMD's goal has always been for the enterprise to be a key driver in company's revenue, market share, brand identity. How does that focal lens with enterprise being a bigger target in 2021 adjust how you approach the product family, the launch, and the messaging?
Well, I think, on the server side, it's of course always been about data center customers. You do have the distinction there between the cloud guys and traditional enterprise. And I will say that I think generally we've found the cloud guys to be a little bit faster to move, a little bit faster to adopt new technology. Neither group is willing to go willy-nilly into embracing a new technology without thoroughly vetting it, without really making sure that it's not going to disrupt their data center operations. But the enterprise end customers, I'd say, are a little bit more conservative. And that's again why we took this very deliberate multi-generational strategy to constantly build the strength of the product portfolio, and also super important, do what we said. I'm sure you recall when we launched Naples, I did put that 3-year generation roadmap out there publicly, and I said we're going to be shipping Milan I said we're going to be shipping Rome in 2019. We're going to be shipping Milan by the end of 2020, which we did. We're launching Milan here as this week as your viewers see this. But we actually began full production shipments in 2020, and it was all about, that was very unusual. Hanging a 3-generation roadmap out there, sort of paints a target on your back for your competition to shoot at. But we thought it was more important to establish a benchmark for execution that our customers could look at and say, okay, this is what AMD said, and they're delivering good product, and they're delivering it on time. They're doing what they said. And I think having that credibility is hugely important for customers to make the investment to embrace our technology, to adopt it. And so a lot of it has been about building the great product that is more and more attuned for the end customer. I mean, throughput with Rome, hugely important to HPC, hugely important to cloud. It was great product for a lot of legacy enterprise applications as well, but they tend to be more per core, per thread performance sensitive. So Milan was always intended to be the part that is just exceptional, absolute leadership for those enterprise applications. And so it's a convergence then of, we've got the right product, we think, for enterprise, without giving up on the throughput performance leadership for cloud. And then we've demonstrated, okay, 3 generations. Here's what we said we were going to do. Measure us. We did it. And so you can trust us. We will be there for you.
We're now a year into this pandemic. Has that put a dampener on any sort of customer expectations, sort of any reluctance to deploy new systems, adopt new platforms?
I don't think it's put a dampener on the intent or the desire. And in fact, I think from that regard, it's been a bit of a tailwind for us, because you see a lot more because of working from home, because everybody now needs a PC. It's no longer a PC per household. It's a PC, or in my case, like, I don't know, 4 or 5 PCs per person. But so it's been a tailwind from that perspective, in enterprise as well as cloud. I will say that I think we did see an impact on enterprise qualifications, let's say in Q2 and Q3 of last year, because people just shut down, and so we had to pivot hard and to set up more remote testing sites, because people that end customers that were testing gear or had intention to qualify gear on site, their people weren't coming in, for a long period of time. So it definitely stalled us, I'd say, for a couple of quarters in terms of enterprise customer qualification in particular. But I think we're well past that at this point.
Yeah, that's good to hear. So, I mean, moving on to the Milan product stack. Milan contains products, focused at general performance, the standard sort of 7003 series, as well as a number of specialized elements in performance per core, such as the F-Series. This is now the second generation of the F-Series, now, coming alongside the general launch. What has feedback been for the F-Series, and how should we look at how customers are deploying this, sort of new segmentation offering?
Well, the F-Series is definitely designed for customers that really need that per core performance or per thread performance. And there's a lot of applications, particularly legacy applications, where that's critically important either for overall application performance reasons or for license cost reasons. So, the F-Series is really targeted at things like EDA, where, perversely, the tools we use to design these highly complicated multi-core devices don't generally scale well with cores. I mean, probably the most common simulation tool is really dominated by, per core performance. And so, we see the F-Series as being perfect for that, and we've had tremendous uptick in like EDA tools. And then there's also a large number of legacy enterprise applications that are licensed on a per core basis. And so if you want to maximize your TCO, it's all about how do I get as few cores as possible. The software cost typically dominates the cost of the hardware. And so, we've got customers that are running 8-core, EPYC, fully loaded, fully tricked out with all the memory you can get, and I/O, but they're running an 8-core high frequency processor, and it's because they're running a database and they're being charged on a per core basis. So we really see the per core or the F-Series is running being perfect for those sorts of applications, license cost dominated, or the peculiarities of the application are that they don't scale well with the increasing number of cores.
The Milan product stack, if we compare it to ROCm, I mean, so ROCm kind of topped out at the 225, 240 watt, and then later on you came on with the HPC 280 watt parts. But this time around, you're launching the 280 watt parts straight out of the gate. For everybody, it drives, it's a higher thermal product, it drives peak performance higher, though you arguably moving slightly more outside the efficiency window. Do you find that customers are looking specifically more at that, just the performance? I mean, having good efficiency is a priority, but is it no longer the key priority in that market?
I would say for many customers, it's all about performance, 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 and so we originally, I think, did not anticipate changing the standard TDP ranges for the mainstream parts. For this generation, we thought we were going to, set, in fact, part of our socket compatibility strategy around ROCm was, set the socket, including the TDPs, the IRM specs, which is just the specifications around the power that needs to be supplied and on the different voltage rails or power rails to the part. We didn't think that would change, when we originally defined them for ROCm, but we got strong feedback from many customers. No, they wanted the flexibility to be able to go higher in power, and that many of their end customers were saying, "Hey, performance is the dominant thing." Until you trip over a certain threshold, and for where the cost of supplying that power or supplying the cooling, really starts to go asymptotically high. And after working, after working with the OEMs, we found 280 watts was sort of that trip point for most of them for air-cooled systems. So we've now got configurable TDP parts. Ian, as as I think you've seen, the vast majority of parts, can operate in a range of 225 to 280 watts, and the customer can make the choice.
I mean, so one of the metrics of these designs is that we have this central I/O die built on a global foundries process, and then 8 7 nanometer dies on TSMC. Um, with the increase in Infinity Fabric performance this generation around, the I/O die is now becoming a higher part of that power consumption. So we're kind of coming up to an I/O power war. Um, what can AMD do on that front? Um, because one could argue it's taking power away from the cores.
Yeah, I would tend to agree with that. I mean, I think that, um, in fact, I do tell the team, right? Every watt we spend on I/O or anything but the core is is um, is power that's not going to the metric that the customers most care about, which is that performance, executing that code. And so, it's a huge focus for us, on this generation and going forward. And we did make the IO die on Milan is actually tweaked from Rome. Originally we were planning on it being identical. It's not. It's very, 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 very close. But most of the changes were actually around power to improve the power efficiency of that IO die, and as because we're going to be running more through it with Milan. I think looking forward, we're going to continue to drive much more aggressive, power sensitive design techniques into the next generation of what we call the uncore. By the way, we're the IO die in current EPYC systems. Basically, the IO die is synonymous with the uncore, everything that's not the core. But just in general, we're trying to drive far more attention. Not attention. We've already got attention. Far more innovation, really, around driving power management and power efficiency in the uncore. You're going to see us continue to drive process very hard on both the cores as well as the uncore. We're going to continue to drive innovation around the interconnect. So Infinity Fabric as a protocol has got a lot of legs, but you'll see us continue to do things to make that more and more power efficient and lower the picojoule per bit of switched traffic.
With Rome, we saw a number of AMD's hyperscaler customers get specialized versions of these processors, whether it's custom core counts, custom power limits, specially bin frequencies. Is this going to be the normal going forward, and are you seeing more demand for these customized variations?
Yes, 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 and yes. I think everyone that's operating at scale is always acutely interested in tweaking, every little knob to extract all of the performance, all of the efficiency. And so, if you double click into it, what you'll see in many cases is, the platform that's being used by a given hyperscale customer, say Tencent. I'm just picking one at random. Um, they don't use all of the I/O lanes, perhaps. That particular configuration that they've optimized for running their instances as efficiently as possible doesn't use all of that I/O. And so the customization of the part, in at least in one regard, is turning that I/O off, fusing it off, so that draws zero power, and diverting that power over to the cores. So you get a higher, base frequency, for example, in that particular case. And so, yeah, I think you should continue. You're going to anywhere where there's a bunch of scale where it's warranted, where it makes a difference for the end customer. We're gonna continue to explore things like that. By the way, I mean that's honestly that's not new. I mean, our competitor as well, and they claim they do a whole bunch of custom parts for the cloud, which is, I think you and I have talked about this before. I- You know, I don't call that a custom part. I'll call that a custom configuration or a tweaked part. But it's the same. It's the same basic part. We've just turned some things off or rebalanced or recharacterized for a particular optimization point.
Well, it's funny you mention competitors because so Intel promotes that more than half of its server total enterprise sales are of the sort of customized variety. Would you care to comment on where AMD sits on that spectrum?
Uh, if I use their definition, it's probably similar. I'd have to think about it, but it's probably similar. Um, by any rational definition, no, of course not. We don't. It's this. Look, because again, you're operating at. You want to be as efficient as possible, and um, we're not doing radically different pieces of silicon for a bunch of different customers. It's crazy. Doesn't help anybody.
Um, I guess the next question is there a minimum order quantity to get a customized part?
Well, for you,
I'll have a special of one. No, two. Let's make it dual socket.
yeah, yeah. Well, you'd probably need a couple of spares, just in case. So no, look, I don't. We don't have a hard and fast rule. It's a conversation. It really depends on it probably. I mean, to be candid, to be utterly candid, it depends on what we think the opportunity is long term. If we think it's a hyperscaler that's going to kick the tires and is going to be relatively modest, volume in this generation, but there's a great long-term prospect, yeah, we'll be much more accommodating. Um, so it's all about what do we see as a long-term opportunity there.
So, what's your opinion on recent news that we've been hearing about processors being locked to specific OEM designs?
Well, the desire there is for security, um, is to try to improve security and try to improve provenance, securing the provenance of a system that's running in somebody's data center, that they can be sure that this is exactly what they intended to buy, that the system provider has signed off on. This is it. This is what we built. Nobody's mucked with it since the time we built it and tested, and you can be assured that that's what you've got. And so that's the intent. It's something we do support. To support that that objective. We don't actually charge for that, by the way. I mean, so that I mean, from our point of view, it's not like we're making more money by doing that. Um, we're trying to meet the requests from our OEM, customers and some of their end customers of getting absolute supply chain security.
So speaking to those security enhancements, obviously, you've already mentioned AMD's partners like Google implement confidential computing on EPYC. So what should we look for in the new security enhancements for Milan?
Well, I think there's a couple. There's secure nested paging, which is so if you look at what we've already implemented in previous generations of EPYC, it was about providing cryptographic isolation, a crypto engine that could encrypt all of the contents of a virtual machine, or really even just a process, such that anybody without that key, even the systems administrator, could not, look into that virtual machine. Um, there was a potential. Well, not in Milan. We made a further enhancement of that with secure nested paging that makes it difficult even for a compromised hypervisor. If somebody, deliberately compromised a hypervisor and the operating system um, had that uh, uh, backdoor, if you will, secure nested paging still protects the contents of the state of that encrypted virtual machine. And then the other one is, for, some of these or return-oriented programming, techniques that have been, led to some of these vulnerabilities, recent vulnerabilities like, Spectre. We were affected by a couple of, variants of Spectre, Meltdown, et cetera. We really haven't, knock on wood, been affected by any of the rest of them. But we do have this thing, Shadow Stack, that helps provide additional security to make sure that, these very, very subtle effects that, some hackers have shown they can extract information from, we're trying to further obscure those and make it difficult to compromise.
Um, the new Milan processors, we've been told, along with supporting 4-channel interleaving and 8-channel interleaving, some SKUs now support 6-channel interleaving. So, are we at a stage where customers want reduced memory channel configurations because DDR is taking up too much physical space?
That's a great question. So we've got some customers that, again, they have a particular optimization point, and they want a particular amount of memory, and they don't want to compromise any performance for getting that amount of memory, or take up the physical space. So instead of having 8 channels per, but previously, as you say, you could get full performance on Rome or in Naples with 8 channels of memory. You could get a pretty good, well optimized and balanced system with 4 channels of memory. You still, obviously, your theoretical bandwidth is cut in half, but it was well optimized. If you had 6 channels of memory supported, you got this somewhat unbalanced condition where latency and throughput to half of those, or I guess a third of the memory in the system would be unbalanced. And so that's what we've really tried to address with the 6 channel, to give that additional flexibility, to right size the amount of memory for your workload without giving up any of the performance.
And so, I mean, as AMD increases per core performance and overall performance of its processor line, going from 2nd gen to 3rd gen, bandwidth out to main memory remains constant because we're limited by 8 channels of DDR4 3200. Is there an ideal intercept point here where at some point we'll need high bandwidth memory for particular customers?
Yeah, so I think you're absolutely right, and really at the top of the stack, that's depending on the workload, that can be the performance limiter. So if you're running top of stack to top of stack parts in certain workloads, you're not going to see as much of a performance gain from 2nd gen to 3rd gen as we might like, just because your memory bandwidth limited at the end of the day. So that's going to look, we're going to keep increasing the performance of cores. We're going to keep increasing the number of cores. So you should expect us to continue to increase the amount of bandwidth, and the memory support. DDR5 is coming, which adds quite a bit of headroom to traditional DRAM. You see more and more interest in using high bandwidth memory for HBM memory, for on package, and I think you'll see some SKUs, in the future from a variety of folks, incorporating HBM. That'll initially be fairly specialized, to be candid. It's HBM memory is extremely expensive, and so it's going to be very much confined initially to applications that are incredibly memory latency sensitive, and then it'll be interesting to see how it plays out over time. You can see a bifurcation coming in the roadmap where there's parts that have different memory hierarchies, maybe with storage class memory as the main store, with an HBM, on-die smaller memory pool as almost a level 4 cache, or maybe a software managed resource that the application can take advantage of. But anyway, I think you'll see innovation in the memory system over the next few years.
So, speaking about innovation, Um, la- End of last year, AMD launched its CDNA architecture and accelerators. With respect to Milan, is there anything here that helps increase performance of those accelerators?
There's some data fabric enhancements in Milan that are sort of subtle that increase the bandwidth to between the cores and the accelerators, particularly in a fully loaded system. Um, the other thing, you'll see if there's a few systems that have been built with Milan that allow you to overclock the PCIe links. And so we support in some systems, turning up the frequency a little bit faster. And then I would be remiss if I didn't say that we also increased just in Milan, we doubled the int8 performance of the part. And so for customers, many customers, quite frankly, still have yet to embrace, GPU accelerators or GPU or FPGA or whatever accelerators. They still want to keep within the standard CPU programming paradigm. And so particularly for inference, we see a number of customers really just running their inference workloads on CPUs. That doubling of the int8 performance really helps quite a bit.
So just to confirm, that's overclocking of the PCI link, not of the core.
Yes. Oh, yes, 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 yes. Sorry. Yes. That's exactly overclocking of the PCIe. And there's yes, overclocking is probably the wrong way to put it. There's the thing ESM, extended speed mode. It's a standard, and we support it.
Okay, that's good to know. And then speaking, final question here on machine learning. Obviously, AMD is moving forward with the CPU side on machine learning, and we've recently seen on the GPU side ROCm 4.0 stack. Try and provide that complete exascale solution for machine learning and HPC. How do you intertwine Milan and the CDNA accelerators for ROCm moving forward?
Yeah, so great question. So I think as we've publicly talked about a number of times, we're going to talk about it at the launch as well. We're incredibly proud to be, part of the effort to build what we think will be the first exascale system in the world, which will be deployed at Oak Ridge National Labs later this year. It's called Frontier, and it really uses a next generation CDNA architecture instinct parts, so something we haven't announced yet. And it also uses a Milan generation CPU. And the reason I say that is it actually is the CPU in that system is something called Trento. It's a sibling of Milan, if you will. It's slightly different. It is physically a different piece of silicon in the I/O die. So it's slightly different from Milan, but the key aspect there is something we think is hugely important going forward, which is it's a coherent system. So the CPU and the GPUs share a coherent, virtual address space. And so the importance of that is you no longer have to spend a lot of programming time as well managing separate pools of memory, fully separate pools of memory, and it greatly accelerates certain workloads being able to have a coherent memory pool sloshed between the CPUs and GPUs. We think this is hugely important going forward, and super proud. The first instantiation is going to be with the biggest machine in the world.
Well, I mean, that's a great little tidbit on Trento. Thanks for saying that.
No
Um,
problem.
would Frontier be the ultimate visualization of that Infinity Fabric all-to-all topology?
Frontier is ultimate realization. No, what is ultimate, Ian? It will continue to evolve over time, but Frontier is a great milestone. Again, you've got this fully coherent Infinity Fabric connecting the CPU to the GPUs and the GPUs to one another. So I think it's a great proof point for the scalability of Infinity Fabric and what it can do.
That's great, Forrest. Thank you for joining me for this interview. good luck with the launch. I know that we've got a few processors in to test, and no doubt if you're free the day of the launch, you can visit anandtech.com and find our review.
Ian, I certainly will. Hey, take care. It's always a pleasure.
Thank you very much.
Bye-bye.